All right, everyone, this video is going to go through this sheet of notes, which there is a blank copy for you in Google Classroom if you would like to print it out or just kind of get a feel for the outline. So this video is going to go over word problems where two or more people are working together to complete a task. So first of all, each piece of information needs to get written as a rate. When you write something as a rate, the amount of time it takes goes on the bottom, and however many jobs they're completing is the numerator. Make sure that all of your time is the same unit. And because they're fractions, we're going to have to solve them by getting a common denominator. All right, so in the first example, Erica mows the lawn alone. It takes her 45 minutes. When Jake mows the lawn, it takes him an hour. How long will it take if they mow the lawn together? So first of all, Erica needs her own rate. And it doesn't tell us that she's mowing like multiple lawns, so we're just going to assume one lawn in 45 minutes. All right, now she's working with Jake, so Jake needs his own rate. Just be careful because it says it takes him an hour. We need to make sure they're in the same unit. So an hour is 60 minutes. So Jake can mow one lawn in 60 minutes. Now they're doing this together. So think about what operation usually implies that things are being put together. And there's the only two people working together, but the new rate is what we're solving for. We're solving for their together rate. It's still just one lawn, but we don't know how much time it will take them to work together. All right, so in this case, you can honestly type this whole thing into the calculator or Desmos. You would just want to make sure that your answer got left as a fraction. So I'm going to do it the long way. The long way would be to multiply the first fraction by 60 because that's the other denominator. Jake's will get multiplied by 45. So Erica's new numerator is 60. Jake's new numerator is 45. And they have the same denominator now. So 60 times 45 is 2,700. So I'm going to simplify the numerator. And now that I cleaned up everything on the left, I'm just going to bring down that 1 over x. And so from here, this is a proportion. So to solve a proportion, we cross multiply and then divide. So 105 times x, 2,700 times 1, and divide by whatever's with x. So about 25.7 minutes. All right, and now we're going to think about our answer, right? Because we don't just want to do a problem without thinking, does our answer make sense? It does make sense that if they mow the lawn together, it will take them less time than if they have to do it by themselves. So that answer seems reasonable. If they do it together, it'll take them a little bit more than 25 minutes to complete. All right, example 2. A large hose can fill a pool twice as fast as a small hose. When they are both working, it takes 2 hours to fill a pool. How long does it take each pipe? It should say how long does it take each hose to fill the pool. So questions like this where you have not an exact amount of time, but one is moving either twice as fast or twice as slow as the other can be a little bit misleading, especially since we're working in terms of time. So remember, with time, the larger the answer, the longer it takes. So Since the large hose is going faster, it takes less time. So we're going to actually use X to be our large and 2X to be our small. So again, even though it's saying the large hose can fill a pool twice as fast as the small hose, that technically means it takes the small hose 2 times longer because the large hose is faster, so it needs less time. If you got those mixed up, when we get to the end and we actually solve it, we can go through how to analyze your answer. So my large hose is 1 pool over X amount of time. I don't know what it is. My small hose takes 2 times as long. They're running together. They're both on, so they're working together. And when they are both working, it takes 2 hours. So their together rate, 1 pool in 2 hours. All right, so again, I need to get a common denominator over here. So if you look, they both already have X, but since this one has 2X and this one does not, I just need to multiply this side by 2, and now the denominators both say 2X. So my large hose has a new numerator of 2. My small hose was still 1. And their common denominator is now 2X. I'm going to clean that up. Bring down the 1/2. All right, and from there, cross multiply. So 3 times 2 is 6. That's 2X, divide by 2. So X is equal to 3. So it makes sense that my large hose will take 3 hours and my small hose will need to take double that amount of time, so 6 hours. So even if you set it up wrong, if you put that the large was 1 over 2X and the small was 1 over X, you would still get the same answer for 3. And since the large one is faster, it should have the smaller answer. So you would have been okay either way. All right, number 3. When Jamie and Jackie work together, they can paint a house in 3 hours. So I have Jamie, Jackie, and when they work together. So this actually tells me when they work together, they can paint a house in 3 hours. So one house, 3 hours is their together rate. It takes Jamie 5 hours. So I know how long it takes Jamie. How long does it take Jackie? So I am solving for Jackie's alone rate. So in this case, we're solving for a part that is being added. So we're going to have to subtract that to the other side. So we're going to leave the 1 over X alone. But on this side, I'm going to need to take that 1/3 and subtract Jamie's amount. I need to take their together amount minus the one person that I know what their alone amount is. All right, so same thing, I want a common denominator. So I'm going to multiply this side by 5. I'm going to multiply this side by 3. All right, so the new numerator over here is 5. The new numerator over here, 1 times 3 is 3. They have the same denominator of 15. I'm just going to bring that down. All right, I'm going to have to move over here to actually solve it. But 5 minus 3 is 2, so my new little proportion is 1 over X equals 2 over 15. Cross multiply, divide by 2. So 7.5 hours. All right, and again, I'm going to look at my answer. My answer does make sense because it should take Jackie at least more than 3 hours to complete it by herself, because 3 hours is if she was working with Jamie. All right, so that's pretty much how you set up every single one of these problems. Each individual component gets their own rate. They're usually working together, so a plus sign. If they were working opposite from each other, that would be a minus sign. And then it equals the rate that they work at together. We need a common denominator, so you just multiply one side by each, kind of cross multiply so you get the same denominator, and then simplify it, cross multiply, solve for x.